Alright, so let's do another one. So they say now we have in the diagram below, the circle at the center at E3:1. We have the coordinate of the center here that passes through a point P, which is 5 to -5. Okay, and then they say now in 4.1 we must go and determine the equation of the circle rather in the form of x squared plus y squared plus ax plus 4 by plus c that is equals to so that is equals to 0. So it means that we have to like go and find the equation of the center and simplify it further. Okay. Right. So now when you look at this equation, you are given the center and we are given the point and circumference, meaning that now it make easy for us so that we can get the radius, because they say that we need to get the radius. It will be, let's say, the constant there, right? Because you're gonna transpose that and you're gonna add with another constant from when you simplify those fractions. I mean those binomials, right? Now let's go and look for the radius, meaning that our radius it will be equal to the distance of EP, right? For which you're gonna say it will be the x of E minus the x value of P all squared plus the y value of E minus the y value of P all squared, right? Then for which the x value of E it is 3 minus the x value of P, which is 5 all squared, plus your y coordinate of E, which is 1, minus by your y value of P, which is -5. So basically I can say positive 5 here all squared. The reason I'm saying positive 5 is because you have 1 minus from the equation that comes with the equation, and then your y value of P it is -5. So it's like negative multiplied by -5, for which you get negative plus 5. For which you get 1 plus 5. Hence I said 1 plus 5. Then what is the distance formula of your the radius or the distance between EP? You get the root of 40, for which your root of 40 it is same as 2 to the root of 10. Now we have the distance, the radius. Now let's go and look for the coordinate of the center. We know it like that is equals to r squared. Then now what is the x value of your center is 3, meaning that we have x minus 3 all squared plus y minus the y value, which is 1 all squared, is equals to what is your r, meaning that your r it will be, let's take root of 42. And remember, if you say root of 40 all to the power of 2, it means that this 2 will cancel this square root, meaning that now our equation will be x minus 3 all squared plus y minus 1 all squared, that is equals to 40. Now let's expand this one and simplify further. So when we expand x minus 3 all squared, it means that we have what? Binomials. So let me change here, and then meaning that you're going to have x minus 3 multiplied by x minus 3 plus y minus 1 and then y minus 1, that is equals to 40. Then meaning that you do the fold method, meaning x multiplied by the x, you get what? X squared. Then x multiplied by -3, you get -3x. As well as when you say -3 multiplied by x, you get -3x. Then -3 multiplied by -3, you get +9. Right? Then we are moving from y values. On y values, we have y multiplied by y, right? For which you get what? Y squared. For which you get y squared. So we get y squared. So y multiplied by y, y squared. y multiplied by negative y, negative y. Then negative 1 multiplied by y, you get negative y. And then negative y, negative 1 multiplied by negative 1, you get positive 1. That is question 40. Then we have what? Like terms, and a constant, Then mean that you have x squared here. Then negative 3x minus negative 3x, it will be negative 6x plus 9 plus your y squared into negative 2y plus 1, that is equals to 40. Now we can transpose this 40 because we have constant 1 and constant 9, meaning that we have x squared minus 6x plus y squared minus 2y. Then when you add 9 with 1, you get 10. So we have positive 10. Then minus 40 that side, that is equals to 0. That's equals to 0. Then now we can see that once you see 10 minus 40, you get negative 30, right? Negative 30. Now let's arrange our equation in the form of the question that asks. We need to go and find the x value added by y value, which is y squared ax, meaning that it will be negative 6x. A because the x value, b, which by will be now negative 2y. Then your c is what? Negative 30. That is equals to 0. Negative 30, 10 minus 40, you get negative 30. Then we have x squared plus y squared minus negative 6x minus 2y minus 30 is equals to 0 into 4.4.1. So let's look at 4.1.2. Now we have a tangent there at this, we must determine the equation of the tangent at the circle P, or at a point P equaling 5 and negative 5 in the form of y is equals to mx plus c. Oops, I erased there, it's fine. Now it means that you must go and look for the radius of, the gradient of the radius for yes, and then you're gonna look for the radius of your tangent. Then from there you substitute the values that are in the tangent to get the equation of the tangent. That's cool, isn't it? So basically what you're going to do, we go and need to persistence. It means now this P, I don't know if I will draw a straight line here. So it means that we have a tangent like here. When you're gonna draw nicely, so this will be your tangent, right? So to get the tangent, the equation of the tangent means like the equation of the straight line, right? Then this, it will be your right. Then it's a big circle, Don't focus on the green one. We are focused on the black one, right? So the distance that I have, this one is your radius for the big circle, because E is the center. Now it means that now you must go and look for the gradient of the radius. So when you're going to look for the gradient of the radius, let's say m radius. Let me say radius. Radius is equals to ye minus y what? P, and also your x value of E minus your y value of P, right? So before you go on, please don't make a mistake whereby you say your y value of E, but here this time around you swap, meaning that you say the x value of P. Now there must be a line, meaning that if you started with the y value of E, it must be 4 divided by the x value of E. Same as on another side, we have a y value of P, and I made a mistake. It's supposed to be the x value of P. So it must be y value of P negative followed by the x value of p, for which your y value of e, it is 1 minus your y value of p minus 5, for which I can say, okay, let me say minus 5. Let me not say positive, it's fine. Then your x value of e, it is 3. Then your x value of p, it is 5. Then how much you are getting there as your gradient? You will get negative 3. Right? Now remember that to get the gradient of the tangent, you're gonna say, because they are perpendicular. Remember, if two lines are perpendicular, it means the radius is close to what? The product of the radius is close to negative 1. For which you can see the gradient of radius multiply by the gradient of the tangent multiply is equal to negative 1. Right? And we have the tangent, then we're looking for the radius, and we're looking for the tangent. Then you're going to divide by negative 3 divided by negative 3, for which your gradient for the tangent, it will be 1 over 3, because when you see negative 1 divided by negative 3, you get 1 over 3. So it means that now your equation now is going to look like this, whereby your gradient of the tangent, it is 1 over 3x plus c. Now to get the value of c, basically we're going to substitute this point, which is what? P as 5 is to negative 5, for which your y value is what? Negative 5, that is equals to 1 over 3, then your x value is 5 plus c, for which you have negative 5 minus 5 over 3. When we transpose 1 over 3 multiplied by 5, right, that is equals to c value. Right, for which your c value, it will be equals to negative 20 all over 3. Now therefore your equation of the tangent, it will be y, that is equals to 1 over 3x minus 20 over 3. Then you get your 5 marks there. Okay, now when you look at 4.2, they are saying that we have a smaller circle that is thrown inside a circle. So the small circle I made it for you, mean that you're going to focus on the green circle right now. And they say that now the line EP is the diameter of a small circle, meaning that now the radius of the big circle now is the diameter of the small circle. I don't know if you understand. So it means that now the radius of a big circle is now the diameter of a small circle. Meaning that to get that, we can say divide by 2, right, to get the radius of that circle. Okay, then now they see that now in 4.2.1, the coordinate of the center of the small circle. So it means now we have a circle in green, as I made sample for you. It means now, let's say the center is here. Now how are we going to find the center there? Okay, and now we can see that we have 2 points, meaning that we have E on the circumference of the circle, and we have another one which is P, 5 and negative 5. So we can see that this point, we have a point here, I have a point here, and then remember that the radius, obviously, it will be the center, or rather the center. You must go look for the center, meaning that is like the midpoint of the two, the midpoint of the radius of a bigger circle. Right, so let's go and look for the midpoint of the circle, for which you can see the midpoint of or rather the coordinate of the center of the small circle, it will be the midpoint of E and P. So the midpoint, it will be the x value of E minus by the x value of P divided by 2 is to y value of P minus, why I carry P guys is E, or E, and the Y value of P divided by 2. And then you're gonna see your X value of E, 3, your X value of P, which is minus 5, right? So we can probably see 5 all over 2, get the coordinate of the center, the X coordinate of the center. Then YE, it is 1 minus the YP, Y value of YP is minus, right? Minus 5 all over 2. Then you get 4 is 2, negative 2. Right? So basically it's when you do the midpoint, so for that you're gonna see the X value of E plus the XP, the X value of P. Ne? Then here you're gonna see the Y value of E plus the Y value of YP, for which it will be 1 plus negative 5, for which you see 1 minus 5. Okay, so for that, then the coordinate of the center is 4 is 2, negative 2. Right, so in 4.2.2 they say that now we must go and look for the length of the radius. So we know the radius of a bigger circle, it was what, root 40, right? For the big circle it was, can we see, big circle, it was root 40, for which is 2 the root of 2 root of 10, right? And then now we're looking for the radius of a small circle, meaning that we can easily say divided by 2, meaning that root of 40 divided or multiplied by 1 over 2, then you get the radius of the small circle equals to root of 10. Or if we didn't see this one, we can normally go and look for the distance of the radius, because we have the center, right? Let's say our center now is 4 is to negative 2. 4 is negative 2, right? Is your what? Your center. Then you're going to say the radius of the small, whereby you're going to see 4 minus 3 all squared plus negative 2 minus 5 all squared. No, minus 1, sorry. Then you get your distance for the small, that is equals to root of 10 as well. When you're going to look for the for the distance. Then now 4.3 says that you must go and look for, okay, they say hence or otherwise determine whether the point C, which is 9 is to 3, lies inside or outside or on this circle center E. So now you're going back to the equation like the bigger circle. You must also determine whether does the point C lies inside or outside or on the circle of the center. So meaning that now we must, okay, right, it's like maybe difference between the distance. So if that point C lies on the circle of your right? So meaning that if your point C lies on this, let's say on your circumference, meaning that the distance between your radius, it must be the same as the one that we have calculated before, root of 40, right? That means that you're going to lie on the circle of circumference. So if the distance is smaller than our radius, it means now our point C is going to lie. Okay, let me make a point, let me make a nice like this. So now, if the distance between, let's say C, I have a point C, the distance between C and E, if it going to equals to the radius for which is root 40, it means that our point will lie on the circle, right? Then point number 2, if a distance from EC is smaller than the distance of our radius, it means that it lies inside the circle. Then if the distance between CE it is greater than the radius of our circle, it means now it is outside there. It means that now it means that our C lies outside the circle. So let's go and look for the distance between those. So we're gonna use E because we have the coordinate of E, and also we have the coordinate of the center E, right? So we're gonna use that as form of our distance. Now the distance of EC, it will be equals to XE minus XE XC all squared plus YE minus YC all squared, right? That is equal to that. So what is the coordinate of center, which is x value of the coordinate of the center? It is 3 minus E, the x value of the C. They say that is what? Can I write it here? Okay, so that I can see it. Okay, fine. The x1 is 9 all squared plus your y coordinate of E is 1 minus the coordinate of YC 3 all squared. Then your distance formula there, you will have root of 40, for which 3 minus 3 minus 9, you get 6, negative 6, for which you say negative to the power of 2, get the positive answer, which is 36. Then here as well you get what? 1 minus 3, you get negative 4. For negative 1 minus 3, you get negative 2, not 4, you get 2, for which it will be 2 to the power of 2, which is 4, right? Then we have 36 plus 4, which is equal to the root of what? 40. So you can see that now the distance between EC, it is equals to the radius of our circle. The distance between EC is equals to the radius of the big circle because we are dealing with a big circle here, right? Then therefore C lies on the circle.